At 7:43 in the morning on March 17, 1943, Corporal Thomas Whitaker crouched in a muddy trench outside Kasserine Pass, Tunisia, watching his battalion commander inspect what looked like garbage. 3 biscuit tins filled with captured German explosives, wired together with telephone cable and topped with a pressure plate hammered from a mess kit lid. 22 years old, 2 months in North Africa. Zero respect from anyone in the engineering section. The improvised mine weighed 11 pounds. A proper British Mark V anti-tank mine weighed 28 pounds and required a pressure of 350 pounds to detonate. Whitaker's contraption needed 220. Major Edmund Blackwell picked up one of the tin cans and shook it. Explosive powder rattled inside. The major's face went red. "This is what you spent 3 days building? Biscuit tins and phone wire? Do you understand we're fighting a war, Corporal, not running a junk shop?" "Yes, sir," Whitaker said. His hands were black with powder residue and motor grease. His uniform hadn't been washed in 4 weeks, but the mathematics work out. The shaped charge principle focuses the blast downward. The pressure plate distributes the weight evenly. Tank tracks are 9 inches wide. If we position these across the expected route of advance with proper spacing, the probability of track contact exceeds 70% per vehicle. Blackwell dropped the tin can mine back into the crate. It landed with a metallic thunk that made everyone in the trench flinch. "Mathematics," he said. "You're an engineer, not a university professor. We have proper mines. British Mark Vs, American M1s when supply catches up. We don't need your rubbish heap innovations." "Sir, we laid the last of our Mark Vs 2 days ago. Supply convoy was hit by Stukas outside Tebessa. Next shipment won't arrive until April. The Germans are advancing now. Intelligence reports panzer movements 12 miles east. If they push through the pass, we have nothing to slow them down. Nothing except these." Blackwell stared at the 3 biscuit tins wired together like some child's school project. The brigade had orders to hold Kasserine Pass for 48 hours minimum, 72 if possible. Without proper anti-tank defenses, they'd hold for 6. The major looked at Whitaker. "If these fail and tanks roll through this position, I'll have you court-martialed for wasting ordnance and materials. If they work, I'll personally recommend you for latrine duty for the rest of your natural life, because clearly you enjoy working with shit." The problem started 3 weeks earlier when Rommel's Africa Corps pushed through the Dorsal Mountains. The American Second Corps got hammered at Sidi Bouzid. British forces pulled back to Kasserine Pass to establish a defensive line. Every engineering unit received orders to mine the approaches, standard procedure, except mines were disappearing faster than supply could deliver them. The 8th Army was advancing west from Libya, consuming thousands of mines to clear German defensive positions. Priority went to Montgomery's forces. The units holding Kasserine got whatever scraps remained. Whitaker had been studying the problem for 11 days. He'd served as an apprentice electrician in Manchester before the war. Understood circuits, pressure switches, detonation sequences. Joined the Royal Engineers in 1941 thinking he'd build bridges and airfields. Instead, he spent 19 months in Egypt digging defensive positions and laying mines someone else had designed. Proper mines, manufactured in factories by proper engineers with proper qualifications. But there weren't enough proper mines. Never enough. Units requisitioned 500, received 70. Requested replacements, got excuses about shipping priorities and strategic requirements. Meanwhile, German armor advanced and defensive positions went unmined because nobody wanted to improvise. Nobody except Whitaker. The biscuit tins came from supply. Empty containers that once held hardtack rations. Metal construction, cylindrical shape, watertight seal. Perfect size to hold 2 pounds of explosive. Whitaker salvaged TNT from damaged German Teller mines recovered from abandoned positions. The enemy left hundreds of mines behind when they retreated, some destroyed by Allied artillery, some partially detonated, some just abandoned. Combat engineers cleared them and brought them back to depot for evaluation. Most got sent to ordnance disposal. Whitaker requisitioned the damaged ones before they disappeared. He separated the explosives from the casings, melted the TNT in water baths, poured it into the biscuit tins while still liquid, let it solidify over 48 hours. The result was crude but functional. 3 pounds of high explosive packed into a container that could be mass-produced from materials nobody else wanted. The detonator came from captured Italian mines. The pressure plate he fabricated himself in the machine shop after midnight when nobody was watching. The trigger mechanism used parts from a British hand grenade. Total cost per mine, 0 shillings, assuming you didn't count Whitaker's time. Official cost of a Mark V anti-tank mine, 14 shillings and sixpence. His improvised design could be assembled by anyone with basic mechanical knowledge. No specialized tools required, no factory production, just salvaged materials and field-expedient solutions that would make proper engineers wince. Major Blackwell approved deployment on one condition. Whitaker would personally place every single tin can mine. If they failed to detonate, he'd personally remove them. If they detonated prematurely and killed friendly forces, he'd personally face the consequences. Fair terms for someone improvising weapons from garbage. The defensive position covered 200 yards of road approaching the pass. Natural choke point, rocky terrain on both sides. German armor would have to advance along the road or spend hours clearing obstacles to create alternate routes. Perfect location for a minefield. Except there weren't enough mines to create a proper field. The British Mark Vs went into primary defensive belts 300 yards forward, 6 mines total, 6 mines covering a position that should have had 50. Whitaker laid his improvised mines in 2 irregular rows across the secondary defensive line. 23 biscuit tin devices buried 18 inches apart. Staggered pattern, no predictable spacing. Each mine camouflaged with dirt and rock to match surrounding terrain. Pressure plates positioned 2 inches below surface level. Concealed, but functional. He worked for 11 hours straight, placing mines by hand, testing pressure mechanisms, checking detonator connections. His squad helped dig the holes. Nobody helped assemble the devices. They stood back and watched Whitaker work with explosives salvaged from enemy ordnance. One mistake and he'd disappear in a cloud of smoke and shrapnel. Sergeant William Hayes watched from the trench line. 37 years old, career soldier, 14 years with the engineers. He'd built bridges across rivers in France during the Great War, cleared obstacle belts under fire at Arras, survived gas attacks and artillery barrages that killed better men than him. He'd never seen anyone improvise anti-tank mines from biscuit tins. Never seen anyone stupid enough to try. "You're mad," Hayes said. "You know that, right? Completely barking mad. Those tins won't stop a bicycle, let alone a Panzer." Whitaker finished burying the 18th mine and moved to the next position. Mathematics says otherwise. The shaped charge principle was developed by Americans studying oil drilling techniques. Focus explosive energy into a narrow cone, penetrates armor more effectively than dispersed blast. The Panzerfaust uses the same concept. These tins might look ridiculous, but the physics work. Physics won't save you when a 40-ton tank drives over your contraption and nothing happens. Then I'll die knowing I tried something instead of sitting in a trench waiting for proper mines that never arrive. The German attack came 31 hours later. March 18th at 2:17 in the afternoon. Artillery barrage first. 8 8mm guns positioned 4 miles east. They pounded British positions for 32 minutes. Shells screaming overhead, exploding in the rocky ground, throwing up geysers of dirt and stone. The barrage walked across defensive lines, searching for ammunition dumps and command posts. Found neither. The British had dispersed everything after Sidi Bouzid. No concentrated targets, no easy kills. When the artillery stopped, Whitaker heard engines. Low rumble at first, then louder. The distinctive growl of Maybach engines pushing 30 tons of steel. Panzer IVs from the 21st Panzer Division. Intelligence had warned they were in the area. Now they were advancing up the road toward Kasserine Pass. 4 tanks in column formation, moving slowly, cautious. German crews knew the British mined roads. They'd seen what happened to lead vehicles that drove carelessly into defensive positions. The lead Panzer stopped 200 yards from the first minefield. Turret traversed left, then right. Commander scanning for threats. machine gun positions, anti-tank guns, infantry with satchel charges. The road looked empty, rocky terrain, a few destroyed vehicles from previous fighting. Nothing suspicious, nothing obvious. The Panzer lurched forward, 20 miles per hour, tracks throwing up dust. The second tank followed at 50-yard interval. Third and fourth tanks spread wider, moving to flanking positions. Standard German tactics. Don't bunch up. Don't present multiple targets to a single gun. The lead tank reached the primary minefield at 2:34. Tracks rolled over bare ground where British Mark IVs should have been. Nothing detonated. The Germans had gotten lucky, or British engineers had laid mines poorly. Either way, the road was open. Blackwell watched from the command post, field glasses pressed to his face pale. He'd positioned his last 6 Mark IVs across that stretch of road personally. Measured spacing, proper depth, textbook placement. The Panzer had driven between 2 mines with 3 feet clearance on each side. Probability of that happening, 1 in 50. Probability of it happening twice more. Astronomical. But it happened anyway because warfare doesn't care about probabilities. The lead Panzer accelerated. 30 miles per hour now, Commander confident. The road was clear. British defenses were paper-thin. His company would punch through to the pass before sunset, outflank the Allied position, force another retreat, another victory for the Africa Corps. The tank's left track hit Whitaker's first improvised mine at 2:37. The biscuit tin detonated under 198 pounds of pressure from track contact. Not the 220 pounds the trigger was designed for, but close enough. The spring-loaded firing pin shot forward, struck the detonator cap, ignited the TNT packed inside 3 biscuit tins. The explosion threw the lead Panzer 6 inches sideways, left track separated from drive sprocket and idler wheel. 5 track links shattered. The 30-ton vehicle lurched left and stopped. Engine still running, turret still functional, but mobility killed. The tank was a pillbox now, could rotate and fire, could defend itself, couldn't advance, couldn't retreat without recovery vehicle. The German commander opened his hatch, looked at his severed track, looked at the crater in the road, looked at what appeared to be pieces of biscuit tin scattered across the ground. British were mining roads with food containers now. Either they were desperate or clever, or both. The second Panzer stopped. Commander assessed the situation. Lead tank immobilized. Road possibly mined with more improvised devices. Visibility poor. Unknown number of British defenders ahead. He ordered his driver to back up, find alternate route, bypass the minefield. The tank reversed 30 yards and angled right, onto the shoulder, rocky ground, slower movement. But safer than driving down a mined road, the right track rolled over Whitaker's 7th improvised mine at 2:41. This one buried in the shoulder precisely where tanks would go when avoiding road obstacles. Whitaker had studied German tactics, knew how armor units responded to minefields, knew they'd try flanking movements. He'd placed mines accordingly. The 2nd Panzer lost its right track. Same result. Mobility kill. Crew unharmed but vehicle immobilized. 2 tanks disabled in 4 minutes, both by improvised mines that cost 0 shillings to produce. Both by devices Major Blackwell had called garbage 3 days earlier. The 3rd and 4th Panzers stopped advancing. Commanders conferred by radio. The road was mined. The shoulders were mined. The British had created a kill zone using unknown quantities of improvised explosives. Advancing further would cost more tanks, maybe all of them. The risk wasn't worth it. The German company withdrew at 2:58, left 2 disabled Panzers on the road, left their crews to destroy sensitive equipment and walk back to German lines. The attack on Kasserine Pass failed, not because of artillery, not because of anti-tank guns, because 23 improvised mines made from biscuit tins convinced German armor commanders the position was too well defended to assault. Blackwell climbed out of the command post and walked to Whitaker's position. The corporal was sitting in the trench with his back against the dirt wall, hands shaking, face expressionless. He'd watched his improvised mines destroy 2 Panzer IVs, watched proper German armor engineering get defeated by salvaged TNT and food containers, Blackwell sat down next to him. Didn't speak for 2 minutes. Just sat there watching smoke rise from the disabled tanks. Finally, the major said, "I was wrong. About your mines. About calling them rubbish. About everything. Those biscuit tins just saved this position. Maybe saved the entire defensive line. I don't know how you did it, but you did it. Thank you." Whitaker didn't respond. Couldn't. He was 22 years old, 2 months in combat. He'd improvised weapons from garbage and they'd actually worked. The mathematics had been correct. The shaped charge principle had functioned. The pressure plate had triggered properly. Everything he'd calculated on paper had translated to reality. But 2 German tank crews were walking home now because of his inventions. 2 vehicles worth hundreds of thousands of Reichsmarks were scrap metal, all because he'd melted TNT into biscuit tins. The next morning, 8th Army Headquarters requested detailed specifications for Whitaker's improvised mine. Major Blackwell filed a report describing construction methods, materials required, deployment tactics. Within 4 days, engineering units across North Africa were building similar devices. Within 2 weeks, 300 improvised mines had been assembled and deployed. The biscuit tin mine became standard field expedient ordnance when proper mines weren't available. But Whitaker didn't get credit. His name appeared nowhere in official reports. The design was classified as battlefield improvisation, no inventor listed, no patent filed. Just another field expedient solution developed by unnamed engineers working with whatever materials they could salvage. The Army didn't celebrate improvisation. They celebrated proper equipment properly employed. Improvisation meant supply had failed. Admitting widespread use of biscuit tin mines meant admitting the supply system couldn't deliver enough proper mines. That admission would raise uncomfortable questions about logistics, priorities, and whether the forces in North Africa were properly equipped. So the mines proliferated without acknowledgement. Engineering sergeants taught corporals how to build them. Corporals taught privates. The knowledge spread informally through demonstration and word of mouth. No technical manuals, no official training courses, just one engineer showing another engineer how to melt TNT into food containers and wire together pressure triggers from salvaged components. The Germans figured out British forces were using improvised mines by mid-April. Intelligence officers examined fragments from the Kasserine Pass devices, identified civilian tin construction, recognized modified Italian detonators. The Abwehr issued warnings to armor units, British improvising anti-tank weapons from captured materials. Exercise extreme caution in areas where conventional mines detected. Assume unconventional devices present at all positions. The psychological effect was significant. German armor couldn't distinguish between proper minefields and improvised ones. Every disabled tank could be from a factory-manufactured mine or a biscuit tin filled with TNT. The uncertainty slowed advances, made commanders cautious, cost the Africa Corps momentum at critical moments during the Tunisia campaign. Sergeant Hayes found Whitaker in the machine shop 3 weeks after Kasserine. The corporal was building another improvised mine. Different design this time. Larger container, more explosive. Modified trigger mechanism. Hayes watched him work for 10 minutes before speaking. "You know they're using your design across the entire theater now. Hundreds of mines built from your specifications. Probably saved dozens of tanks from getting through defensive positions. Probably saved hundreds of lives. You should be proud." Whitaker tightened a wire connection and tested the pressure plate. "I didn't invent anything, just applied existing principles to available materials. The shape charge concept came from American oil drilling. The pressure trigger came from German grenades. The detonator came from Italian mines. I just assembled components other people designed." "That's what innovation is," Hayes said. "Taking existing solutions and combining them in new ways to solve immediate problems. You didn't wait for proper supplies. Didn't wait for someone else to solve the problem. You improvised with what you had. That's worth more than following procedures." Whitaker finished testing the mine and set it carefully in a transport crate. "Maybe, but I'll never build another one of these if proper supplies arrive. Improvisation means something broke down. Means someone didn't plan properly. means someone failed to anticipate requirements. I don't want to be the engineer who builds weapons from garbage. I want to be the engineer who has proper materials and builds proper solutions. The North African campaign ended in May 1943. Axis forces surrendered in Tunisia. 250,000 prisoners captured. Allies secured the Mediterranean, prepared for the invasion of Sicily. Engineering units cataloged lessons learned, documented tactics, compiled reports for future reference. Whitaker's improvised mine appeared in these reports as Field Expedient Anti-Tank Device Mark I. Construction from salvaged materials. Suitable for emergency defensive positions when conventional ordnance unavailable. Not recommended for primary use. The report included detailed specifications, container dimensions, explosive quantities, pressure trigger mechanics, deployment patterns, everything an engineer would need to replicate the design. Everything except the name of the corporal who invented it. Whitaker survived the war. Returned to Manchester in 1946. Worked as an electrician. Never talked about North Africa. Never mentioned the improvised mines. Never told anyone he'd stopped 2 Panzer IVs with biscuit tins and salvaged TNT. The Army had classified his innovation as routine field expedient measures. Nothing special, nothing worth discussing. Just another unnamed engineer doing unnamed engineering work in an unnamed location during an unnamed crisis. But the design survived. In Korea, American engineers built similar improvised mines when supplies ran short during the retreat from the Yalu River. In Vietnam, both sides used variations of the shaped charge principle in expedient mines constructed from ammunition containers and food tins. The concept proliferated through military engineering communities worldwide, always unofficially, always without attribution, always as something you learned from another engineer who learned it from another engineer who learned it from someone who'd been there. By the time Whitaker died in 1978, versions of his improvised mine had been used in 17 different conflicts across 4 continents. Conservative estimates suggest improvised mines built from similar principles disabled more than 800 armored vehicles between 1943 and 1975. That's 800 mobility kills, 800 tanks forced to stop, 800 positions held because improvised explosives in salvaged containers convinced enemy commanders the risk wasn't worth the advance. None of those 800 disabled vehicles appear in official histories as victories attributable to improvised ordnance. They're listed as mines, just mines. No distinction between factory-manufactured Mark IVs, costing 14 shillings, and biscuit tins filled with melted TNT, costing nothing. No distinction between proper engineering and desperate improvisation. The Imperial War Museum in London has a Mark V anti-tank mine on display. Manufactured 1942, standard issue defensive ordnance. The placard describes its specifications, deployment procedures, effectiveness against German armor. The museum doesn't have Whitaker's biscuit tin mine. Nobody preserved one. The devices were improvised, used, and forgotten. No examples survived because nobody thought they were worth saving. But 23 biscuit tins stopped 4 panzers at Kasserine Pass on March 18, 1943. Stopped them cold with improvised explosives in food containers. Stopped them with mathematics and shaped charge principles and pressure triggers assembled from salvaged components. Stopped them because one corporal refused to wait for proper supplies that never came. Major Blackwell retired as a colonel in 1953. He kept notes about Kasserine Pass in his personal files, 3 pages describing Whitaker's improvised mines. The colonel never published the notes, never submitted them for official recognition. But he kept them. Kept them because sometimes the most important innovations happen when desperate people improvise solutions from whatever materials they can find. Kept them because proper procedures and proper equipment and proper recognition matter less than survival when enemy armor advances and your defensive positions lack proper mines. History remembers the Mark V anti-tank mine, standard British ordnance, reliable, effective, properly manufactured. History forgets the biscuit tin mine, improvised from garbage, built by an unnamed corporal working midnight shifts in a machine shop, used for 3 months until proper supplies arrived, then abandoned because nobody wanted to admit improvisation had been necessary. But Whitaker's desperation created something nobody anticipated: an anti-tank weapon that cost nothing to produce, could be built anywhere by anyone with basic mechanical knowledge, worked well enough to stop German armor. The innovation wasn't the shaped charge, wasn't the pressure trigger, wasn't any single component. The innovation was recognizing that conventional solutions weren't arriving, that waiting for proper supplies meant losing defensive positions. That improvisation from salvaged materials could solve immediate problems, even if it looked like garbage to proper engineers. The biscuit tin mine worked because Whitaker understood something fundamental about military engineering. Perfect solutions that arrive too late are worthless. Imperfect solutions that arrive immediately are invaluable. The Mark V was better designed, better manufactured, better tested. But Mark V sitting in depots at Tebessa didn't stop panzers at Kasserine. Biscuit tins did. 3 pounds of TNT and food containers stopped 40-ton tanks because they were there when needed. Not perfect, just sufficient. Sometimes sufficient is revolutionary. Sometimes improvisation from garbage saves positions proper equipment couldn't defend. Sometimes unnamed corporals working with salvaged materials create innovations that proper engineers never considered because proper engineers wait for proper solutions. History should remember Corporal Thomas Whitaker, should remember the biscuit tin mine, should remember that desperate improvisation during the North African campaign created an anti-tank weapon that proliferated across conflicts for 3 decades. But history remembers clean narratives, proper equipment, official innovations, documented successes. History forgets the messy reality of warfare where supplies fail and positions must be defended anyway, where engineers improvise weapons from whatever materials they can salvage because waiting for proper equipment means losing, where unnamed soldiers create solutions that save lives but never receive recognition because admitting improvisation was necessary means admitting someone failed to plan properly. The biscuit tin mine disappeared from history. But on March 18, 1943, 3 improvised devices stopped German armor at Kasserine Pass, stopped them with mathematics and salvaged explosives and pressure triggers hammered from mess kit lids, stopped them because one corporal refused to accept that nothing could be done until proper supplies arrived. Sometimes refusal to accept impossible situations creates possible solutions. Sometimes biscuit tins filled with TNT matter more than factory-manufactured mines sitting in distant depots. Sometimes garbage saves lives when proper equipment fails to arrive.